So what we're doing today is we are multiplying matrices. We did a kind of multiplication on Friday. We did the scalar multiplication, where we took a constant, just some number, and multiplied it by a matrix, and we multiplied it by everything in that matrix. So what we did Friday was a number times a matrix. What we're doing today is a matrix times a matrix, and it's a whole other thing. And there's this basic skill that I want to talk about right now that's really going to help us when we do the matrices, okay? And what this basic skill, I'm just making up stuff. Basic skill is called is a dot product. So let me show you an example. Bless you. A dot product is just where you take two numbers, and I'm not even going to write them in matrix form just yet. It's just going to be two numbers, 2 and 3, times another two numbers, 4 and -6. And a dot product is defined as this. You do two things. You multiply corresponding entries, and we talked about that last week, right? Whatever's in the same place. You multiply corresponding entries, and then you add those numbers. I should just say you add them. Whatever you get when you multiply, you add them together. So if I were to do the dot product of these random numbers that I just gave you, right, I just made them up. 2, 3, 4, -6. Here's how that would go. The first entry here would get multiplied by the first entry here. And then the second entries would get multiplied by each other. So we would do 2 times 4, which is 8, and 3 times -6, which is -18. And then we would add them. And that would give me -10. And I would have this one answer. And that is what my dot product is. If I had, let me give you another baby example. Let's say I had 1, 5, and I want to multiply it by 2, 0. Think in your head, which numbers are the first entry for both of those parentheses? What's the corresponding entry for 1? It corresponds to the 2 over here. Those are the first entries. So we multiply them. 1 times 2 is 2. And then the second entries are 5 and 0. We multiply them and get 0. But the dot product says now we add those two things. And once we do that, that's my final answer, is just 2. And it doesn't have to be just 2 things. It could be 3 things. It could be 1, 2, 3 times 4, 5, 6. It's the same idea. You multiply the things that are in the same positions. So we would do 1 times 4. We would do 2 times 5, because those are corresponding. They're in the second position. And the 3 and the 6 are in the third position. And so we just do 1 times 4, 2 times 5, 3 times 6. Okay, I multiplied those, and then you add them together. And you have just that one answer. And this is called a dot product. And here's how we're going to use this today. We're going to use this in matrix form, but we're going to be doing, instead of like just a horizontal row of numbers, matrix form for this last example would look like this. It would be a row that's 1, 2, 3, times a column. That's 4, 5, 6. And here's the most basic matrix multiplication we're going to do. a row times a column, you still are doing first entries times first entry, second entry times second, third times third, and then adding them together. Okay, and this is the way we are going to multiply matrices, but with even more rows and more columns, right? So all of this was just to introduce you to an idea of a dot product. And now we start the actual lesson. Okay, so now get your notes, have your pencil ready. Those of you who are copying in Zoom, take a minute and copy this page. If you're watching the video and you're copying your own notes, you need to copy down all of this. Okay, so here are the important things I want to pull out of this slide. The first comes from the very first sentence. It says, in order to multiply matrices, the number of the columns of the first matrix must match the number of the rows of the second. And this is just the way that matrix multiplication is defined, the way it was created. So if matrix A, so we've got two random matrices A and B, okay? So if matrix A has these dimensions, M times N, right? Some random number of rows, some number of columns. Matrix B must have these dimensions, where the second number of the first one matches the first number of the second when you're comparing their sizes or dimensions or their order, okay? You see how in both positions it has an N? That means it's the same number. So these two things have to match remember this is rows by column. So the column of the first matches the rows of the second. And then the leftover things, the M and the P, that actually is going to be the dimensions of your answer matrix. And I'm going to show you a little trick to set this up every time before you begin to help you keep it straight. So let's say you're multiplying two matrices A times B. And I will always do this. I will write the dimensions of the first matrix next to the dimensions of the second one. And I will remind you to check some stuff. I will remind you to check that these numbers are the same. That's the columns of the first have to match the row of the second. And then I will remind you that these on the outside are going to be the dimensions of your new answer matrix. So answer matrix is going to be M times P. So the rows of the first will be how many rows your answer has. The columns of the second will be how many columns your answer has. And we'll do this, with repetition, you'll get the hang of that better. Okay, here's the next slide that I want you to copy down. So those of you in Zoom or watching the video, please do that now. And this is where we're going to talk about the dot product again and write notes on it. So you'll feel comfortable with it. So something very important on the screen is from the first sentence where it says, the order of the matrices is important. When you're multiplying regular numbers, like 9 times 3, it doesn't matter which order you multiply, you get the same answer. 9 times 3 is 27, and 3 times 9 is 27. That's the commutative property of multiplication. But this is not true for matrices. So what it says right here, matrix multiplication is not commutative. So the order of the matrices is important. So A times B, when you're talking about matrices, is not going to give you always the same answer as if you did B times A. Sometimes you might, but not as a rule, like not usually. So keep that in mind when you're setting up your problems, okay? And then this is the screen where I want to review what we talked about at the beginning about the dot product. So the second sentence, to find the entries of your new matrix, you multiply the ith row of A with the jth column of B by summing the products. Basically what you're doing is you're find the dot product of A's rows and B's columns. Find the dot product of A's rows and B's columns. So here's an example. To find the dot product, here's a row times a column. And this is a very basic example, right? So here's my A and my B. And A is 1 by 3. And B is 3 by 1. So we check that the columns of the first match the rows on the second, and that's true. 3 columns on the first, 3 rows on the second. And my answer matrix is going to have these dimensions. It's going to be a 1 by 1. So this is going to be one number. So that's a 1 by 1. And here's how we find the dot product. We multiply rows by columns. We multiply their corresponding entries. So the first entry in A times the first entry in B. So that's 2 times 0, or just 0. And then we do the second entry in A times the second entry in B. And that's -3 times 2, which is -6. And then the third entry in A times the third entry in B, which is 8 times 4, which is 32. Now I just gave you, that's 3 numbers, but I just told you that the answer matrix is a 1 by 1. So the dot product is multiplying corresponding entries and then adding them together. So 0, -6, 32 is 24, 26. And so that's my answer here. So that's a really basic example. 1 row, 1 column, but most of our matrices are going to have more rows and columns than that. And so all we have to do, it's the same math. You just have to be very careful with keeping everything straight and that you don't lose your place, and that you follow all the steps of the process, and then you're going to be gold. Any questions about this, or anybody still need this up before I change the screen? Before we complicate things, make it harder, we'll level up. Okay, here's the new slide for you to copy if you're copying in Zoom. So the main idea on this slide is that if the number of columns on the first matrix does not match the number of columns on the second, you can't do the multiplication. Okay, so you have, let's say you have your A times B, and it's like, so here's an example. And A is 2 by 2, but B is 3 by 2. If these numbers don't match, the columns on the first and the rows on the second, then you would say not applicable, right? Because if you're doing rows times columns and they don't match, you're going to run out of stuff. There'll be no corresponding entries then. So it's the rows of the first times the columns of the second. So they have to match exactly the number of them. So always check that before you get started, because otherwise you might end up doing a whole bunch of math and then only to find out it wasn't applicable anyway. It wasn't defined, and you'll be frustrated. Okay, so here's where we do some examples. So Zoom, here's a new slide. So copy those matrices down. I'll give you a minute before we talk about one, or the first example. All right, so we have these three matrices. We have two examples. The first one is to do A times B. The second one is to do C times B. So here's that little trick that I showed you. Do this every single time before you begin to save yourself unnecessary work, okay? Take the dimensions of each one and write them underneath the problem that you're trying to find. So A times B, the dimensions of A are 2 by 2. So I'm going to write that under here. And the dimensions of B are 3 by 2. And these are the numbers that have to match. And they don't. So this is not applicable. So I can't do that. Because I have to do the rows times the columns, and so that they have to be exactly the same amount. So then we go to CB. So I do the same thing. I put the dimensions under each letter. So the dimensions of C are 3 by 3. That's rows by columns. So if you need to remind yourself of that, because it was a long weekend, remember it's rows first by columns second. Rows go left and right, columns go up and down. And the dimensions for B are 3 by 2. And notice how here these two numbers match. Notice also that C and B don't have identical dimensions. For addition and subtraction on Friday, we learned that the dimensions have to be exactly the same. But that's not the case for multiplying matrices. The only things that have to be the same are the columns on the first and rows on the second. And then these other two numbers, these are going to be the dimensions on your answer matrix. So what I like to do is set myself up like a blank answer matrix before I even begin, because it helps me keep it straight where my answers are supposed to go. So I literally do this. I set up a blank matrix and I put little lines like for my spaces that I'm going to fill in with my answers, and I do it 3 rows by 2 columns. So that would look like this. 3 rows by 2 columns. That's where my answers are going to go once I find them. I like to do that because it gives me a visual organization, because otherwise, once we get started, there's going to be numbers everywhere, and it could be harder to keep track of where they go. All right, so now that I have that set up, I'm going to write my matrices out down here. So here's C, 2, -1, 2, 0, 3, 0, 1, 4, 3. Times B. And remember, the order matters, so we have to put C first and B second. So the first thing we're going to do is the first row of A times the first column of B. Now that's going to give me one number. That final answer is going to be one number, and it's going to go in my answer matrix at row 1, column 1. You see how that corresponds? Multiply row 1 times column 1, that answer in your answer matrix is going to be in row 1, column 1. Okay, so let's do that math. So we're going to do the dot product. So the first entry in the row is 2. So this is the first entry here in the row, and this is the first entry in the corresponding column. So I'm going to do 2 times 3. And then I move to the second entries. The -1 here. Use a different color so you can see they match. So the -1 here and the -2 here. That's -1 times -2. And then their third entries. The third entry in the row is 2. The third entry in the column is 5. And we multiply those together. So those are 10. The second entries give me positive 2, and the first entries give me 6. And what I do with all three of those things is I add them. So that's 8 plus 10 is 18, and that gives me one answer in my, that just gives me one number of my answer, 18. And so now maybe you can see why I set up my answer matrix very particular, because this is going to be lots of numbers floating around. And now you can fill in the answer matrix in whichever order you do. What I generally do is I move across the rows. So my next number I would find would be right here. I go left to right. You're welcome to go from top to bottom. But here's my point I'm trying to say. So I highlighted in my answer matrix row 1, column 2, right, where that little blue circle is. To get that answer, I do the corresponding row and column on my multiplication. So if I want row 1, column 2, I need to multiply row 1 in the first one times column 2 in the second one. Okay. So I'm doing row 1 in the first times column 2 in the second. I do their first entries, I multiply their second entries, I multiply their third entries, and then I add them. So I'm going to be multiplying 2 times 0, right? 2 is the first entry in the row, and 0 is the first entry in the column. And then I go to their second entries. The second entry in the row is -1. And the second entry in the column is 1. And then I go to their third entries. The third entry in the row is 2. The third entry in the column is also 2. So I multiply those things together, I get 0, -1, 4, and then I add those. And that goes in the first row, second column, right there. Now I'm going to get you started on the next one, and then I'm going to give you a few minutes to try and work your way through the rest of the problem, okay? So it doesn't really matter where you go next. For example, let's say I wanted to do this answer now. So I'm in my answer matrix, and I highlighted the very bottom left spot. That's row 3, column 1. That's the row and column I would use on the problem. I would use row 3 times column 1. All right, so try that one next. I'll check it with you, and then I'll leave you alone to try and finish out the rest. So right now, do row 3, column 1, multiply their corresponding entries, multiply the firsts, multiply the seconds, multiply the thirds, add them, and see what you get. Zoom, put your answer in chat when you get that one, just so I can see how we're doing, or time-wise. So right now we're doing the answer for row 3, column 1. And I'll check with you, and then I'll give you some time to finish out the rest. Yes, you're welcome. Who's working on this in class? Who's actually working the problem? Because I just want to know where we are. Are you working, Zach? No? Kahlo, are you working? Yeah, Sierra, are you working on it? Yeah, Kat, I just wanted to know. I would just know. Yeah, because I just want to see how you do. Right now, we're just working on row 3, column 1. I just want to see how y'all are doing on that, and then I'll give you some time to finish the problem by yourself. Oh, Jack and Peyton, very good. Those are correct answers. Jack and Peyton, if you want to just keep going and finish, you can. Braxton, that's not it. Let me see if I can figure out what your mistake is. Oh, I know what you did, Braxton. I think you used a +2 for the second entry. Kaya, that's correct. In fact, Braxton, I'm pretty sure that's what you did. Right here, did you use a +2 instead of a -2 for that second entry in the column?
Yes.
Yeah, okay. Yes, Luis. Those of you working in class, do any of you have a number yet that I could hear and see how you did? What do you have, Zach? 10, awesome. Did y'all get 10? What'd you get, Sierra? 3. Let me see if I can figure out your mistake. You got 3. Let me see, you're here so I can compute. Yes, Brax, that's correct. Okay, so y'all are getting 10. So I'm just gonna, for those of you who didn't get 10 and you can't figure out, let me go over it, and then I'll give you some time to finish out the rest by yourself. So here's how you get 10. It's the 1 here times the 3 here. So 1 times 3, that's the first entries. And then the 4 times the -2. And then 3 times 5, right? Those are the third entries, the third position. And then that's 3, -8, 15, and you're adding them. So that's -5 plus 15, and that's 10. So go ahead and take a minute and find the other 3 numbers, and then we'll come back together and talk about what you should have. You've probably already discovered it's super easy to make a mistake, and then it's just long and tedious, and that's why we have computers. Picture computers were invented so we didn't have to do matrices by hand. I can't think of any other reason than that. Well, maybe phones. Raise your hand if you'd like some more time to finish. Zoom, unmute yourself and let me know if you'd like some more time. Okay, I don't hear anybody, so let me tell you what the answers are. Hopefully you got I'm going to read it across in rows, okay? So the first row is 18.3. The second row is -6.3. And the third row is, oh, yes, 10, 10, 10, sorry. All right, did anyone in class get those all correct? Zoom, put yes in the chat if you got all those correct.
Mrs. Forrest, could you work out how you got 10 on the last one? Because I got 11.
Absolutely. That was going to be my next question, is any that you all wanted to see worked out. So 10 on the bottom right.
Yes.
Okay, so that would be row 3, column 2. So the first entries are 1 and 0, which is 0. The second entries are 4 and 1, which is 4. And the third entries are 3 and 2.
Oh, I see my mistake. I
You see your
missed
mistake?
multiply.
Okay.
Yeah.
Does anybody else want me to work one of the numbers that they can't find their mistake? Okay, we have 2 more examples. And this next one should go much faster, right? Once you get the process down, me explaining it makes it take super long, right? But now I feel like I've got the hang of it. It should go much faster. The only problem you'll find is that you'll make simple math mistakes and it messes everything up, but that's not the same thing as not knowing what to do. Before I change the screen, does anybody need this up or have a question? Good job, Peyton. Thank you for your response. Okay, here's one, before you even try either of these, I want you to do the trick with the dimensions, where you're comparing, setting them up. So this is what I want you to do for both of them before we even do math. I want you to write the dimensions underneath. So B is 3 by 2, and A is 2 by 2. Would you say yes or no? Can this multiplication be done?
Yes.
Yes, perfect, thank you. Because you're seeing if these match. The rows of the first and the columns of the second. So yes, C can be done. And then these other 2 numbers are the dimensions for your answer matrix. So your answer matrix is going to have 3 rows and 2 columns. Write out very nicely. And then try D. Do that little trick with B times C, put the dimensions down and see how they compare. And this one cannot be done because you're looking to see if these match. And they don't. So this is not applicable or undefined or whatever you want to call it. So we can't even do D. So we can do C, and I want you to try it by yourself for a few minutes. Be sure that when you go to set up that multiplication, you write B down first, because the order matters when you're multiplying matrices. So B times A. So take a few minutes and do that. Zoom, please put done in the chat when you've done this problem. Please and thank you. Hi, Sophia. We're just finishing the notes. And the video will be up in the Google Classroom here in just a little bit after the lesson. And Sophia, we have a quiz on Wednesday. It's on everything that we did last week.
Miss F.
Mhm.
So, for the one in between 18 and 10, I got -6.
18 and 10. Are we on the last problem?
Oh no, I'm on the one that's on the board.
Between 18. What am I missing that you're saying 18?
Oh no, you see how it says 18 and it has a 6?
Oh,
I'm saying
I froze my screen. I'm sorry.
it's okay.
Yeah, okay, tell me again.
I got -6 between 18 and 10.
You got -6. Right here?
Yeah.
Yeah, let me see. I did not realize my screen was unfrozen. I mean, was frozen. Good gosh. Yeah, -6. It goes 18, 3, -6, 3, and then 10, 10.
I like this lesson. It's pretty easy.
Yeah, once you get the hang of it, right? And then this was what I wrote for the next screen already. Sorry, you guys. I had frozen it to do attendance, and then I forgot to unfreeze it for you guys in class. And Zoom, if none of you are putting done in the chat, I think you need more time. So I'm craving feedback. Okay, thank you, Arden. Yes, I will go over it. Maybe I'll do 2 numbers and then give you some more time. So remember that we're doing, it's rows times columns. So when I multiply this row, rows of the first one times columns of the second. So I'm just going to start with this. Row 1 times column 1. What you're multiplying is corresponding entries. So the first entry in the row that I highlighted is 3. And the first entry in the column I highlighted is 2. So I'm talking about the first entry here and the first entry here. Multiply those, you get 6. But then you stay here, that's not my answer. Now I do multiply the second entries. The second entry in the row is 0, and the second entry in the column is 1. And we multiply them, and we get 0. And then what we do with those two things is add them. So you multiply corresponding entries. So you multiply the first entries, the second entries, the third entries, the fourth entries, however many you have. Once you get all those multiplications or products, you add them all up, and that's just going to give you one single number. And that number goes in your answer matrix, and it matches what you just multiplied. If you multiplied row 1 times column 1, then that answer goes row 1, column 1. Thank you, Peyton. Thank you, Jack. And now let's do row 2, column 2. Row 2, column 2. You're multiplying the first entries together. The first entry in the row is -2. The first entry in the column is -1. And -2 times -1 is +2. Now you move to their second entries. The second entry in the row is 1. And the second entry in the column is 3. And 1 times 3 is 3. And then you add them. 2 plus 3 is 5. Now, once you get that number, you might be lost. Like, where does that go in my answer? All you have to do is think about, okay, it was the second row times the second column. So this answer goes second row, second column, which is right here. And that's how you can keep your place no matter where you are. Just think about that like that. You get it now and you're done. Okay, so I feel like everyone's done. So I'm just going to tell you the answers instead of working out every single thing. So the answer is, and I'm going to go across the rows. So 6, -3, -3, 5, 12, 1. Who got all those correct? Who didn't get them correct, but now they're good? You could get them correct now. Okay, is anybody cannot find their mistake? I can work any of the numbers that you want. Okay, so if there's no questions, we are done. Your grade for today is to put a picture of the notes in your Google Classroom. I highly recommend you work your homework problems as soon as you can while the lesson is still fresh in your brain. Because don't forget, most students are like, oh, okay, I get it. I get it now. I don't need to do the homework problems. Yes, you do. You need to do the homework problems. The repetition is good for you so you don't get to the test day and go, I thought I understood it, but